So the overall procedure, if I can summarize, is you're going to have an outer loop for the initial distance, let's say x0, right? Goes from, let's say, x0 min, x0 max, right? Actually, you won't be able to choose like all the possible x's in that interval, but like you can sample with a pretty fine delta x, right? So you're going to sweep over these different initial starting points, and for each x0 you said we are going to sample, right? So sample, let's say ti and the delta vi. All right, so for I equal to 1 to a big N, let's say n being the total number of samples, and then compute two things. Compute my like say estimated time of arrival ETA being a function of x0 ti delta vi, right? So that's
you can still control that by determining when you want to switch on the cold gas thrusters. But if you want to get there as fast as possible, you want to sort of coast as long as possible and turn on the cold gas thrusters only at the last minute.
That's right.
So you have to have a rule for determining when you turn the cold gas thrusters on.
That's right. So this contains exactly the rule you just described, right? So basically, we're going to talk about how to compute the ETA, but like of the overall procedure is the following. So the ETA contains the optimal strategy to use for firing the cold gas thruster. That's right. And also compute I crash. I is an indicator function being 0 or 1 that is dependent on initial position ti and delta vi. Again, this is not just doing random things on the cold gas thruster, but like try to, if I decelerate as hard as I can, would I be able to stop before I reach the surface of the asteroid? Right? Okay. So this is doing the samples. Now, after doing the samples, compute from the samples, compute expected time of ETA. That only depends on x0, right? And compute the probability of crash, which also only depend on x0. So this would be the overall strategy I use, right? So here we only have two random variables. In the more realistic problem, there are usually a lot more random variables, but like the procedure doesn't really depend on how many random variables you have, except for if you have more random variables, you just sample a little bit more random variables, and the procedure will be the same. Yes?
On MATLAB, how do you sample from like a piecewise function, like or distribution?
Right. So in MATLAB, okay. So now let's get into how do we do each component. All right. So first of all, let's get into any questions on the overall procedure before we dive into each component? No? Okay.